So now that we've talked about what a spliterator is in general, now that we've talked about the fields that are part of the PhraseMatchSpliterator, let's go ahead and actually see how it's implemented for this particular example. So here's the constructor for PhraseMatchSpliterator. I've actually abbreviated it a bit. If you actually take a look at this, you'll see it's very, very, very complicated regular expression. The regular expression, in a nutshell, is taking the phrase. Remember, the phrase could be it'll contain multiple words, like "to thine own self be true" or something. And what we do is we take the phrase and we split off any trailing or leading white space. We then tell it we want this thing to be treated as a single entity, so it won't match as a sub-phrase. It'll just match directly as the phrase. And then we go through and we do a bunch of replacements using the replace all method. And one thing we do, for example, is we take any group of spaces and convert it into a single space. And then we also go ahead and convert things so that we make each word within the phrase be that word specifically. So again, if you read the code, you'll see all the nitty-gritty details of the regular expression. It's very complicated. But the long and the short of it is we want to make a regular expression that matches this phrase in the input string. We're then going to go ahead and compile that regular expression, making the pattern matcher be case insensitive and search for phrases that split across lines. So if there's new lines, it'll search across new lines. So now we have a pattern. We take that pattern and we associate that pattern with the input, which is passed in here, so that's the work of Shakespeare. So we now have a pattern matcher, which we call PhraseMatcher, and that's what we're going to use in a second. And then we have a few other things. We update the phrase, we update the input, and then we go ahead and figure out what the split size should be. And what we're going to do is we're going to take the length of the input and divide it by 2, and what that'll end up doing is for a given work of Shakespeare, when we do the parallel streams version, it'll go ahead and basically use up to 4 threads at a time to search the input, and in parallel. And we'll talk more about that when we talk about parallel streams. Ignore that for right now. Here's the tryAdvance method. This is called by the Java 8 Streams framework to attempt to advance the spliterator by 1 word match. So what it's going to do, as we'll see, is it's going to look in the input string to see what matches, if anything, that phrase, and it'll keep track of how many times it matches and where it matches. This particular method is passed a consumer called action, and that's used to pass the results back by reference to the streams framework. So every time tryAdvance is called, if it succeeds, it'll give back a consumer that indicates where the match occurred. Here's how it does that. The first thing it does is it checks to see if there's any phrases in the input that match the regular expression. And the find method of the matcher class will go ahead and start looking in the input from left to right, from the beginning towards the end. And if it can identify anything in that input string that matches the regular expression pattern, it will return true. And it'll also stash away internal to itself where the match occurred. We'll see how that works in a second. So if find returns true, that means it found a match. So if we negate that and it returns false, in other words, negating true returns false. So if it didn't find a match, we return false. And that basically says, we're done. Don't keep trying to do anything further. So the return value of false from tryAdvance is an indication to the streams framework, we didn't find a match, don't keep looking. But if we don't return false, we return true, or sorry, if we don't return false right here, that means we found something. And what we do then is we go ahead and accept a result into the action. And accept is going to make a new result object, and it's going to keep track of where the phrase matched. So PhraseMatcher.start is the index of where the phrase actually matched in the input. So we're going to make a new result object, keeping track of the index where it matched. We're going to store that into the action, and then we're going to return true, and giving true here is an indication to the streams framework, I found a match, do something with it, like create an element that will be part of the stream. Oh, and also allow tryAdvance to be called again. So returning true means tryAdvance again. And obviously, the streams framework will store the action, the consumer action somewhere, put it into the stream data structure it's creating, and then it'll call tryAdvance again, and we'll go back to that whole process to check to see whether we can find any more matches or not. And it'll keep doing this until we hit false. So that's basically what is going on here. This is what gets used by the this is all that gets used for the sequential stream variant of PhraseMatchSpliterator. And that's because we have a single thread of control that's trying to find the matches in one thread, and it's going to return a stream of all the matches. There's another method called trySplit, and this is the method that gets used when you have a parallel stream. And we'll talk more about this later, but what it's going to do is it's going to recursively call itself, much like your trySplit did for the unsynchronized array spliterator, and it'll go ahead and try to split the input up into chunks, and then it has those chunks be searched in parallel to see where the phrases match. And as you might expect, under the right circumstances, like large input, such as large works of Shakespeare, splitting things up into chunks and then searching them in parallel speeds things up even further. We'll talk about that later. We're not going to talk about that right away. But that's sort of the most aggressive form of using parallel streams, is by splitting the input up into chunks as well. OK, so that's the end of the Spliterator example. I think you'll agree that this Spliterator is more complicated than the one that you wrote for the unsynchronized array class, where you just split everything up until you got sort of atomic-sized chunks of 1 or 0, and then you would consume them one at a time. That was a pretty straightforward use, because you're just basically taking the entire unsynchronized array, recursing until you get something of size 1, and then you go ahead and return fault, null, but otherwise you go ahead and split your array up into 2 chunks, and then 4 chunks, and then 8 chunks, and so on, until you reduce it to the final atomic sizes. So this implementation is more complicated. You will definitely see the complexity when we talk about the parallel version of this stuff later, because it's a lot more complex.